If we have, say, the square root of 9, there's another way to write the square root of 9 without the radical symbol. Okay? That would be 9 to the 1/2 power. It's just another way to write the square root of 9. It's a different notation. It means the same thing. It's still equal to 3. But it's just another way of writing it. Okay, so if I had the cube root of 8, the way that we write that to a power would be 8 to the 1/3 power. So the index of the radical, you know, with square roots, we usually don't write that index in there. It's kind of understood that there's a 2 right there. So the index of the radical is always going to be the denominator of the fractional power, or of the rational power. So the cube root of 8 is 2. Well, 8 to the 1/3 is still 2. That's because, you know, 2 times 2 times 2 is 8. So you can rewrite these radicals as rational powers. Now, if I have something like this, 2 to the, let's say I had 2 to the 3/2 power. Now 2 to the 3/2 power, still the denominator tells you to take the square root of 2, but we have a numerator now that's not a 1. So what does that mean? Well, there's two ways to write this. If you have a numerator in your rational power that is not 1. So one way to write this is you go ahead and say that's going to be the square root of 2, and then you can write the power on the outside of that. And this top power is the power that you would write on the outside. It's the exponent. Another way that you can write that is the square root of 2 and put the 3 under here with the number 2 to the 3rd power. So this is two different ways to write it. Sometimes writing it one way will allow you to simplify it. For example, this way that I wrote it the last time. You know, what's 2 to the 3rd power? That's 2 times 2 times 2, so that's 8. So this would be the square root of 8, which then we could write as the square root of 4 times the square root of 2, or 2 square roots of 2. Alright, so sometimes rewriting, using that fractional power, rewriting will allow us to simplify an answer. Now officially, like in general terms, what your book would have, and what most books have, is like this: a to the m over n power is equal to the nth root of a to the m is equal to the nth root of a to the m. Now that's all just general, a bunch of variables, so sometimes that doesn't make as much sense, and that's why I didn't write that down first. But in general terms, no matter what the numbers are, that will always be true. Alright, so what will the equations look like that we need to solve? Well, we're going to have two types of equations that we're going to solve. Either the top number, that's the numerator of the fractional power, either it's going to be odd or even, right? So it's going to be an odd number or an even number. All numbers have to be either odd or even, right? Except one that I can think of, except 0, right? So, and if they're whole numbers. So if the top here, if the m or the top, the numerator of your rational power is even, then you need to put a plus or minus whenever you raise both sides of the equation to whatever we're going to do. And I'll show you. I just don't want it to confuse you right away, but I'm letting you know there's a difference whether that power is even, that's going to be in the numerator of the fractional power, or odd. So if the m is even, so if m, that's the numerator of the fractional power, rational power, is even, then the way that we solve, let's say we have x to the m over n power equals some number. I'm going to let some number be k. The way that you solve is you raise both sides of the equation to the reciprocal power. So what's the reciprocal of m over n? It would be n over m. And I know that this may seem a little confusing because we don't have any numbers in here, but I'll do an example with numbers. So anytime you multiply reciprocals, it doesn't matter what the numbers are. If they are reciprocals and you multiply them, you will always get 1. If you think about it. Any two reciprocals, if you multiply them together, you get 1. Well, that's what we do when we say a power to a power. We multiply them together. So if we multiply those two together, you get 1. Now, if the m is even, then when we raise both sides of the equation to that power, we have to put a plus or minus in front of one side. And so we do that usually with our number side. So let me do that with some numbers in there so it makes a little more sense. Let's say that I had x to the 2/3 power equals 4. All right, so to solve this equation, I raise both sides to the, what's the reciprocal of 2/3? 3/2. So I raise both sides of the equation to the 3/2 power. Now, since our m, this is our m right here, that number right there, that's our m. M is even. The number 2 is even. Okay, so since m is even, when I raise both sides to the reciprocal power, I'm going to have to put a plus or minus in front of the right side. Now remember, I told you when you multiply power to a power, you always multiply. And when you multiply powers that are reciprocals, you always get 1. Right? That would be 6/6, which is 1. And that's what we always want x to be raised to a power to solve for it. We want it to be x to the first. We usually just don't write the 1 up there. So that's why we're doing it, to make it x to the first. Okay? Now 4 to the 3/2, we need to simplify that if we can. We may not be able to, but if we can, we need to simplify it. So the first way that I always try, if I have a 2 down here, that means I'm going to be taking the square root. So if I'm going to be taking the square root, if I know that you can take the square root of the number, then I'll do that first. So I can take the square root of 4. What do I have to put in front of my answer? Plus or minus. So it's going to be plus or minus the square root of 4 raised to the 3rd power. So that's plus or minus, what's the square root of 4? It's 2, so you'll have 2 to the 3rd power. So plus or minus 2 times 2 times 2 is 8. So that's my answers. I have 2 answers there. X is equal to plus or minus 8. Positive 8 and negative 8. So if m is even, raise both sides to the reciprocal power and put a plus or minus in front of the right side when you do that. Now, if you understand that, then you will understand what to do if m is odd. Because if m is odd, you just don't put a plus or minus in front of your answer when you do that, when you take the raise both sides. So if m is odd, you do not put a plus or minus in front of the right side. We're just going to say that. Do not put a plus or minus in front of, I'll say either side of the equation. All right, so let me work one like that. So let's say that I had 3x to the 3/4 minus 6 equals 0. Now I want to do everything in my power, no pun intended, everything in my ability, with my abilities that I have, my math superpowers. I want to get x by itself. So I got to do everything I have to do to make that x by itself. So since I have a minus 6, I want to add 6 to both sides. So that's 3x to the 3/4 equals 0 plus 6 is 6. Now, I still don't have my x by itself, so I'm going to divide both sides by 3. So I have x to the 3/4 equals 6 divided by 3 is 2. Now, look at the numerator of the fractional power. It's odd. When it's odd, I'm just not going to put a plus or minus on the right side. Alright, so to make this x to the first power, I have to raise both sides of the equation to the reciprocal power, which would be 4/3. Alright, so on the left side, when you multiply those powers, you get 1. So I just have x to the first equals, I am not going to put a plus or minus because I'm not supposed to. And so I have 2 to the 4/3 power. Now, you may see your answer written as that, but technically there is a way to simplify that if you want to get technical. And how would that be? Let's see. We can either write it as the cube root of 2, which I can't do. I can't do the cube root of 2. But I can write it as the cube root of 2 to the 4th. So that really doesn't get me anywhere. Or I can write it as the cube root of 2 to the 4th. Okay? So that would be the cube root of 2 times 2 is 4, times 2 is 8, times 2 is 16. Now the way that you simplify a cube root, remember, is you have to have a number that when you say it times itself twice, you would get that number. And can we break up 16 that way? Yes. We can break that up to the cube root of 8 times the cube root of 2, because 8 times 2 is 16, and I can take the cube root of 8. The cube root of 8 is 2. So technically, the answer can be written like that. Now, if you work it out and you simplify it all the way down and you don't see this answer, or you plug that into your homework and it tells you, I'm sorry, we want the answer in another form, then go back to this original form here, just 2 to the 4/3 power, and put it in that way. It just really depends on which answer is down there, because both answers are correct. You know, this answer is correct and this answer is correct. It's just written in a different way. All right. Now, the last type of equation we're going to look at, equations that are in quadratic form. Now, there's two ways to work these out. One way gets very technical and uses something called U substitution. That's the way that I've always taught it. One of my colleagues, co-workers, brought up the point that, well, hey, why don't you try to teach it like this and see if it makes more sense to them? Another way. So that's what I'm going to do this time. I'm going to teach it a different way. So if you do watch any videos and you see me working out these equations in quadratic form, I do have a lot of videos up that I use U substitution to work things out. So either way, you can get the same answer though. It's like one of those things where you can do it more than one way, still get the same stuff. So what is an equation in quadratic form? Well, it's an equation that kind of looks like a quadratic because of the way that it's set up. Think about quadratic equations. They were equations that were in the form ax squared plus bx plus c equals 0. And if you have all three terms, the easiest way to solve those was by factoring. At least that was the quickest way, right? Maybe we have trouble with factoring, so it's not the easiest way for you. But as far as being efficient and being quick, it's the quickest way to work out and solve for a quadratic equation. Well, the type of equations that we're going to look at, one type that are in quadratic form, look like this. X to the fourth minus 10x squared plus 9 equals 0. So you see, it kind of looks like a quadratic equation. The only thing is the powers are different. So we have three terms. It's a trinomial. The thing that makes this in quadratic form is that the first power here is twice the second power. So you see, like right here, in the quadratic, this power is 2, and that's twice the power of the middle term, 1. So this power here is 4. That's twice the power of the middle power, which is 2. So that's really what puts it in quadratic form. Now, we can break this up and factor it just like we were factoring quadratic equations. The only difference is, instead of putting x and x, what do I have to put first? X squared and x squared. Because that's what you have to multiply together to give you x to the fourth. X squared and x squared, right? And then let's look at the factors of 9. So we have 1 and 9, or we have 3 and 3. So if I want to multiply two numbers together and get a plus 9, and I want to add two numbers together and get a minus 10, then which ones should I choose? 1 and 9, and I need to make them both what? Negative. So minus 1 minus 9, like that. So that's how that factors. Now that we have a factor times a factor equals 0, we use what's called the zero product principle. The zero product principle says if you have one thing times another thing set equal to 0, then you can set each one of those things equal to 0. Each one of these factors equal to 0. Now we can use the square root property, or the square root method, to solve these. That's the fastest way. So x squared equals, when you move the 1 over, it becomes a positive 1. Take the square root of both sides. X equals plus or minus the square root of 1 is 1. Let's solve the other equation. Plus 9, x squared equals 9. Take the square root of both sides of the equation. X equals plus or minus what? 3. Is that hard? Is that okay? You think y'all can do that? I think y'all can. It's just like quadratics. Now the next type that we're going to look at, you probably won't recognize that it's in quadratic form at first because it's going to have fractions in it, which some students, when they see fractions, their brain just kind of turns off and you're like, I just don't want to do this. But this is still in quadratic form. So let's look at this one. 5x to the 2/3 plus 11x to the 1/3 plus 2 equals 0. Now you see the three terms, so that kind of looks like a quadratic. But what really makes this in quadratic form was what I told you would make any trinomial in quadratic form. It's that this first power is twice the middle power. If you say 1/3 times 2, you get 2/3. So since there are all three terms here, and this power here is twice the middle power, that puts it in quadratic form. So what that means is we can make two parentheses side by side. In one of the parentheses we're going to put 5, and then whatever this middle power was, you have to put that 5x to the 1/3, and then 1x to the 1/3. So now what do? I look at the factors of the last number, right? 1 and 2. Now since this was a 5, I can't add them together and get the middle number. That only works if you have a 1 in front of that first term. But we only have one set of numbers to look at, 1 and 2. So let's just put 1 and 2 here. And since you want a positive in the middle, make them both positive. Now the way that we check and see if we have it factored correctly is we multiply the outer numbers and multiply the inner numbers and add them together, and if that gives us the middle term, we have it factored correctly. So if I multiply the outer numbers, that's going to be 10x to the 1/3. And if you multiply the inner numbers, that's going to be 1x to the 1/3. When you add those together, you get 11x to the 1/3. So if that's with the number in the middle, then we factored it correctly. And that is the number in the middle, so we factored it correctly. Alright, so now that we have this thing factored, we need to set each factor equal to 0. So 5x to the 1/3 plus 1 equals 0, and x to the 1/3 plus 2 equals 0. And we work out each one of these equations, and we're going to get our answer. Let's see what we get. So minus 1, minus 1. So 5x to the 1/3 equals -1. Divide by 5, divide by 5. So I have x to the 1/3 equals -1/5. So when we get to this point, what do we have to do? We have to raise both sides of the equation to the reciprocal, which is going to be 3. Now, was the numerator there even or odd? It was odd, so that means that we don't put a plus or minus, right? Alright, so the left side of this equation becomes x to the 3/3, or x to the first. And then what do I get when I say a negative times a negative times a negative? You get a negative, right? If your power is ever odd and you're taking a negative number to an odd power, your answer will be odd. And then what's 1/5 times 1/5 times 1/5? 12, right? No. 1/5 times 1/5 times, if you need to write it down, write it down. 1/5 times 1/5 times 1/5. 1 times 1 times 1 is 1. 5 times 5 is 25. Times 5 is 125. So my answer is negative 1 over 125. Alright, so that's one of my answers. Let's see what my other answer is. Minus 2, minus 2. So x to the 1/3 equals negative 2. Raise both sides of the equation to the reciprocal power. That's 3. Alright, so x to the 1/3 raised to the 3rd, that's going to be x equals negative 2 times negative 2 times negative 2. Negative 8. So my two answers are x equals negative 8 and x equals negative 1/25. Alright, I want to work one more because I know you have one like this on your homework. Which I'm sure all of you are keeping up to date with. You wait until that last day, it's going to be too much to work. Alright, so x plus 3 square roots of x minus 4 equals 0. Now at first, when you see this problem, you might think, hey, this is a radical equation, so I need to start solving the... Remember how long those radical equations take, though? Sometimes there are better ways. Alright? Remember, you can rewrite a radical, a square root, as what power? X to the 1/2. Alright, so I just rewrote my middle term as 3x to the 1/2. Well, now I see 3 terms, and look at the powers. The power of the first term is x to the 1st. The power of the middle term is 1/2. And if I say 2 times the middle power, I do get the power of the first term, right? 2 times 1/2 is 1. So that means that we can solve this by factoring just like we would a quadratic. Got to be careful though. It's very tricky. It's my advanced calculus teacher used to say all the time. It's very tricky. Alright, so what would I need to write as my first terms so that when I multiply them together, I will get x to the 1st power? It's very good. It's always going to be whatever power is here in the middle. Alright, so x to the 1/2, x to the 1/2. If you're wondering why multiplying those together give you x to the 1st, remember when you multiply bases with powers, you add the powers, right? And 1/2 plus 1/2 is equal to 1. Alright, now we need to look at the factors of the last number. And this one, luckily, had a 1 in front, so we're going to be able to use that trick to pick the numbers that we use. So we have 1 and 4, and we have 2 and 2. Now, when we multiply the numbers together, we want to get a negative 4. When we add the numbers together, we want to get a positive 3. So how could I write my numbers so that whenever I multiply them together, I get a negative 4 but when I add them together, I get a positive 3. -1, positive 4. All right. So let's see. X to the 1/2 minus 1 equals 0. And x to the 1/2 plus 4 equals 0. Alright, so x to the 1/2, when I move that 1 over, equals 1. I need to do what to both sides of the equation? If that's to the 1/2, the reciprocal is 2. So x equals 1. So x squared, or I'm sorry, square both sides again, and we get x equals -4 times -4, positive 16. So my answers are x equals 1 and x equals 16. Right. Every time, yes, you do have to plug them back in because that doesn't work. But the 1 works, right? Because you could do 1 plus 3 times 1 minus 4 equals 0. So that would work. So the answer is yes, plug them back in.